Rescript supports if-else construct, just like every other mainstream languages. However, unlike the JavaScript counterpart, it is an expression, meaning they actually evaluate to their body's content. Because it has a value, you can assign it to a variable. Let's take a look. So this expression evaluates to a string data type because in the if branch, we have string data type here, and on the else branch, we have also string data type. We can't have different data types between the if and else branch. For example, let's say we change it to Rescript will complain. It says this has type string but somewhere wanted int. If we don't have an else branch, that means the data type evaluates to unit type. The unit type is indicated by the open parenthesis and close parenthesis syntax. For example, this works because show promotion here has a return type of unit type. So this is how you indicate a unit type. When we don't have an else branch, Rescript wants this if expression to have a return type of unit type, which is basically the same as. Rescript also has ternary expression just like JavaScript. But this is less preferable than just writing an if-else expression. Now let's talk about for loops. For loop that iterates from a starting value up to and including the ending value looks like this. Loop is actually an expression as well, just like everything in Rescript. The return type is the unit type, which is the open parenthesis and close parentheses. Let's prove it. So Rescript complains, it says this has type unit but somewhere wanted int. Basically, this means that the loop type is actually a unit type. Now let's talk about while loops. While loop keeps executing its body code while its condition is true. Alright, so I think this is a good time to solidify your understanding about scope and mutability. Suppose we want to naively write a while loop just like what we know from our experience with other languages. Okay, so we are confused now because Rescript gives us a weird error. It says, did you mean equal equal here? If you haven't watched my previous video about let and mutability, go ahead and watch it now and come back to this video after you watch it. We see that in Rescript, you can't really mutate a let binding just like this. So you're wondering, what if I add a let keyword in this line? Rescript gives us a warning that we are not using the variable break inside the if branch. How so? Because the let binding here lives in a different scope than the let binding outside of the while loop. If we try to run this code, it will result in the loop never ends. Okay, so what should we do then? As I've explained in the let and mutability video, we need a ref keyword to signify that a let binding is mutable. We need to add the ref keyword here, and in order to read a ref variable, we need to add .content. Now we can reassign the ref variable. We can use the .contents as well. Or we can use the colon equal syntactic sugar. Same like for loops, while loops also have unit data type as its type. Let's prove it. Rescript rightly complains because while loop has a unit data type, not an integer. Previously, we have seen the option type that we wrote ourselves. The good news is that option pattern is very common in Rescript, so Rescript provides it for free. So we can just use it anywhere we want. We can definitely use it in if expression, for example. Now, option type is fine and dandy, but what if we want to have a computation that expresses either a result or an error string? We can use the result type. As with option type, result type is also very common in Rescript, so Rescript has it built in so we can just use it anywhere. If you erase one if branch, notice that Rescript doesn't complain at all. But this code is potentially a source of bug because we forget to handle an OK branch. Can we do better? Yes, in fact we can. In the next video, I'll talk about pattern matching, a more powerful construct than an if expression. That's all for today. If you like this video, don't forget to click like and subscribe. See you next time.